This topic is chapter 2 of your EMath syllabus. It is called Advanced Linear Inequalities. Okay, there are some concepts in basic linear inequalities that is covered in Sec 2. Okay, if you need, go back to MA 202 to revise. Okay, first and foremost, the concept of a number line. If x is, this is called strictly lesser than, that means it cannot be equals to 3. When you see strictly lesser than, your dot cannot be shaded and it's going to the left side because it is lesser than 3. The mouth always point to the bigger value. Okay, if x is strictly greater than 1, it is a non-shaded circle, it goes to the right side. If x is less than but equals to 2, this means that x can be equals to 2. Okay, so it is a shaded circle, it is going to the left side. If x is greater or equals to 0, again it is a shaded circle and it is going to the right side. Okay, some of the number system you have to know before we proceed. A natural number is the same as a positive integer. It starts from 1. Okay, a whole number difference from a natural number is there is a 0 inside. Okay, integer can be positive or negative. A rational number is the most important that students screw up. It can be expressed as a fraction or integer. Sometimes, 0.25. It is a decimal. Then students say this is an irrational number. However, remember 0.25 is 1/4. So this is a rational number. Okay, same thing, 0.3 recurring. We know that this is 1/3. Any decimal that can be expressed as a fraction is a rational number. Okay, the irrational number are those that cannot be expressed as a fraction or integer. We know square root 2, square root 3, square root 5, etc. We also know that pi is irrational. Okay, so all these are irrational numbers and you must know all these that are the prime numbers. Let's recall some important concepts before we continue to the two main applications of linear inequalities advanced. Okay, when you divide by a negative number, do remember to flip the signs. Okay, so let's say you are told to solve this equation. I bring negative 3 plus 3 over become negative 3 and then I will get negative 2x is smaller equals to negative 15. So I want it to be x. I have to divide by negative 2. When I divide by negative 2, can you see there's the sign flips. Okay, it becomes x greater equals to 7.5. When I draw this on the number line, okay, it means this way. 7.5 is in between 7, 7.5 and then 8. Okay, if I can be equals to, I have to shade the circle and it goes to the right side. The smallest integer is equals to 8. The smallest prime number, the next prime number after 7.5 is 11. Okay, the smallest cube number is 8. What are all the cube numbers? 1 cube is 1, 2 cube is 8, 3 cube is 27 and so on. Okay, the next square number is 9. Okay, everything that's on the right side of 7.5 and the smallest rational number is 7.5 because 7.5 can be represented as 15 over 2 is a fraction, so that's why it is a rational number. Now we talk about application of simultaneous inequality. Okay, simultaneous is like simultaneous equation. After you work out two inequality, you may have two answers in an inequality. There are two possibilities. The first one, which is the most common one, is you get x smaller equals to k as well as x greater equals to k. H must be smaller than k. Okay, when you draw these two inequalities, so for example the first one, x smaller equals to k, is this x smaller equals to k, it goes to the left side with a shaded circle. X greater, let's change this to x greater than k, it is a not shaded circle going to the right side. Then this is the part that they overlap, you see, and hence this is the answer. When we represent it, the answer right, you have to put the solution as this way. What I'm trying to show here is trying to show you that these two parts overlap, and this is the solution. H is here, K is here. When we put it in the solution, this is called X is in between, okay, or greater than H but smaller than K. Okay, so this is the part that they overlap. When two inequalities does not overlap, which is not very common, there will just be no solution. Okay, so be careful. If you cannot visualize, then please draw it out. Okay, not all the time you will get case number 1. Sometimes you may get case number 2, and then you have to say that there are no solution. How do we apply it into the question? Okay, so when we have this kind of simultaneous inequality, you have to take this and work it out first over here. Then the second one will be this box. Work it out over here. Okay? After you work out your inequality, you realize that x is lesser than 5 but greater or equals to -3. In a number line, it just means that it is this way. Greater equals to -3 but it is smaller than 5. Okay, so that's why we represent the answer in a in-between format. X is greater equals to -3 but smaller than 5. Okay, so the gist of it is to do the first two equation first, as inequality first, then do the second two inequality first, then combine the two inequality. Okay, this is a type of question that student will always screw up. So I wrote that as a concept first. Now, if I have x is greater equals to -3 but smaller equals to 5, this means that x can be -3, -2, -1, 0, 1, 2, 3, 4, 5. When you square each of the values, you will get 9, because -3 square is equals to 9. -2 square is equals to 4. That's how I get all these values. Then you realize that if I want all these values, what is the smallest value of all these values? It's actually 0. Okay, you put in any negative number square, you will become positive. So any values that passes through 0, -3, -2, -1, 0, 1, 2, all the way to 5. This guy passes through 0, then when you square it, right, the smallest value of a x square is equals to 0. Then you have to see -3 square and 5 square. Which one gives you the higher values? This should be 25. Okay, yeah, this should be 25. Then I know that the maximum value is 25, but the minimum value is 0. Okay, again, you see the second scenario. I drew from -6 to 2. So y is in between -6 to 2. Or everybody I square will become positive except for 0. So as long as you pass through 0, the minimum value of the y square is going to be 0. Be careful of the maximum value. -6 square is 36. 2 square is 4. Which one is bigger? 36 is bigger. So that's why the maximum value of y square is equals to 36. Okay, and thirdly, if it didn't pass through 0, then don't be tricked. Then x is in between 3 and 9. If you square it, then x square is in between 9 and 81. Don't be tricked. It doesn't pass through 0, then you know the 0 thing doesn't come into play. Okay, so for this type of question, we usually use the extreme values to get the answers. Okay, what do I mean by that? Number 1, I want to get the greatest value of x plus y. Okay, so let me just write over here to avoid any confusion. X is in between -3 to 5, y is in between -6 to 2. Okay, if I want the greatest value of x plus y, then it's just straightforward 5 plus 2. That is 7. Others, it might be a bit tricky. For example, y minus x. Okay, so if I want y minus x, because x there is a negative value, right? Yeah, I will have to choose, okay, the biggest value of y, that is 2. okay? Minus, for x, I can be -3. So you realize that minus minus become plus. That's why 5 is the greatest value of y minus x. Okay, the greatest value of x over y. This kind of question, there are two possibilities. If I want the greatest value, I use the greatest value of x, okay, over the greatest positive value of y. So 5 over 2, and that is equals to 2.5. Okay, now let's check whether the -1 can give you a bigger value. Because if I want x over y, I can also use -3 divided by -6. Because negative divided by negative will give positive. But this is equals to half. Okay, which gives you the biggest value? It is still 2.5, or still wins. Okay, next, for x squared plus y squared, these two I went through with you above. So when I square this, the highest value is 25, the lowest value is 0 because x passes through 0. For y, the highest value is 36, which is -6 squared, but the smallest value is 0 because it passes through 0. If I want the least value of x squared plus y squared, that would be 0 plus 0, it is still 0. Okay, then the next, x minus y squared, that could be quite a bit of combination over here. Okay, so I look at, again, let me write it over here, x minus y bracket square. Okay, so I know that x is in between -3 to 5. I know that y is in between -6 to 2. What would x minus y be in between? So I look for a few combination. Okay, 5 minus 2, that's going to be equals to 3. Okay, if I want the largest value of x minus y, right, usually we use the largest value of x minus the smallest value of y. That would be 5 minus -6. Okay, and if I want the smallest value of x minus y, I will take the smallest value of x minus the largest value of y. -3, okay, -2. So x minus y is in between -5 and 11. But if I square it, x minus y square will be in between -5 square and 11 square. Which one will give you a bigger one? 1, 2, 1, 11 square. And because this passes through 0, the minimum value of x square is equals to 0. Okay, so the least value of x minus y square is equals to 0. Something wrong over here, it should be 0. Okay, I got a lesser value of this. Okay, next, the least value of x times y. Again, I look at these two. X is in between -3 to 5. Y is in between -6 to 2. Okay, for x, y, the smallest value is going to be, now especially when there's a negative, right, we always try to lose a negative number to a very small negative number and pair with a very big negative number, and that will give you -30. Okay, whereas for the biggest value of x, y, it is actually -3 multiplied by -6. I write down here 5 multiplied by -6. So x, y, the smallest value is -30 and the greatest value is 18. Okay, and this is how we do inequalities questions with x square and y square, and this is how we do inequalities. This is how we do inequalities questions within 15 minutes.